In this video, we will do an exercise about charging by contact, knowing that whenever we say charge, we mean electric charge. For this purpose, we have three identical metal spheres, S1, S2, and S3, and we should complete this table and justify the answers. Before we start, we will state the law of conservation of charge. Charge is neither created nor destroyed. It can only be transferred from one system to another. Hence, according to this law, in an isolated system, the net charge remains the same. Now let's go back to the exercise. In general, when there is contact between two identical and conducting solids S1 and S2, and assuming there is conservation of charge, for example, when S1 and S2 are mounted on insulating stands and the system made up of S1 and S2 is considered isolated, we can apply this formula where Q1 and Q2 are respectively the initial charge of S1 and that of S2, and Q1 prime and Q2 prime are respectively the final charges of the same solids. In fact, when we put S1 in contact with S2, a transfer of electrons occurs between them. Assuming there is conservation of charge, the net charge of the system after the contact is equal to the net charge of the system before the contact. Q1 prime plus Q2 prime, which is the sum of the charges after the contact, is equal to Q1 plus Q2, which is the sum of the charges before the contact. Since S1 and S2 are identical, Q1 prime equals Q2 prime. Replacing Q2 prime by Q1 prime in the first equation, we get Q1 prime plus Q1 prime equals Q1 plus Q2, or 2Q1 prime equals Q1 plus Q2. By dividing this last equation by 2, we get Q1 prime equals Q1 plus Q2 all over 2, also equals to Q2 prime. So based on this formula, we can complete the table. Before any contact, the charges are given. Then S1 is isolated, thus it keeps the same initial charge minus 18 microcoulombs. To calculate the final charge of S2 and that of S3, we add up their initial charges, then we divide the result by 2. This gives plus 2 microcoulombs for each one. Then S2 is isolated, thus it keeps the same initial charge plus 2 microcoulombs. To calculate the final charge of S1 and that of S3, we add up their initial charges, then we divide the result by 2. This gives minus 8 microcoulombs for each one. Then S3 is isolated, thus it keeps the same initial charge minus 8 microcoulombs. To calculate the final charge of S1 and that of S2, we add up their initial charges, then we divide the result by 2. This gives minus 3 microcoulombs for each one. Note that the law of conservation of charge is obeyed at any of these four states, and the net charge of the system made up of the three spheres is a constant that is equal to minus 14 microcoulombs in this case. And here is how the table becomes. This is all for this video. Thank you for watching.